Hey everyone, welcome back. You know how we love to tackle some seriously big questions on this show, right? Well, get ready, because today we're diving into one that really pushes the limits. What if the universe isn't what we thought it was?
And by that we mean, what if the universe is a shell?
Exactly. A shell. Like, seriously. Someone sent us this mind-blowing research paper arguing just that, and, well, we had to dig into it.
Buckle up, folks.
So before we get too far, let's lay a little groundwork. We've all heard about the Big Bang and how the universe is constantly expanding.
Right, the whole expanding like a balloon thing.
Exactly. And a big part of how we understand that is something called the cosmological principle. Basically, it says that the universe is roughly the same everywhere you look on a large enough scale. Kind of like if you zoom out far enough, the Earth just looks like a smooth blue marble.
Yeah, like a cosmic smoothie, everything's all blended and consistent.
Makes sense. But, like all good theories, there are a few hiccups, right?
Oh, definitely. Some things just don't quite line up with this perfectly smooth universe idea. That's where things like dark matter and dark energy come in.
Ah, yes, the great cosmic mysteries. We know they have to be out there doing their thing, but we can't actually see them or fully understand what they are.
Exactly. And that brings us to this shell universe theory. What if, instead of everything being evenly spread out, all the matter we can see is actually squished into this relatively thin layer like a shell?
Okay, so instead of a smoothie, picture a jawbreaker. Hard candy shell on the outside, and who knows what's inside.
Pasty analogy. And it highlights just how different this idea is from our usual picture of the cosmos. We're talking about a fundamental shift in how we view the structure of the universe itself.
So if we are living inside this giant cosmic jawbreaker, this shell, wouldn't we be able to tell? Like, shouldn't we see it?
That's where things get really tricky. See, the way space-time works, it might be impossible to directly observe this shell, even if we're trapped inside it. It'd be like trying to find the edge of a shadow from within the shadow itself.
Whoa, so it could be all around us, but we're stuck here, none the wiser.
Exactly. And what's even wilder is that this shell idea might actually explain some of those big cosmic mysteries we've been struggling with. Remember the Hubble tension?
Oh yeah, it's like the universe can't decide how fast it's expanding. Different measurements give us different answers, which drives scientists up the wall.
Right. And this new theory suggests that, well, our measurements might be thrown off by being inside this shell. Our position within it could be skewing how we perceive things like gravity, making the universe seem like it's expanding at different rates depending on where we look.
So imagine you're trying to figure out the size of a house, but you're only allowed to look at the shadows inside one room. You might get a completely wrong idea.
Exactly. The shell universe theory is saying we might be making the same kind of mistake on a cosmic scale. Our limited perspective from inside the shell might be leading us to misinterpret what we see.
Mind blown. But there's got to be a catch, right? I mean, a universe shaped like a shell, that can't be the whole story.
You're right to be skeptical. As intriguing as this shell idea is, there's one major hurdle it has to overcome: stability.
Stability. Okay, break it down for me. What's the issue?
Well, imagine trying to build a house of cards, but on a cosmic scale.
I can already tell this isn't going to end well for the House of Cards.
Not a chance. Even the slightest nudge, any tiny imbalance, and the whole thing comes crashing down. That's essentially the problem with a shell-shaped universe, at least according to our current understanding of physics. Shells, especially on a universal scale, are just not very stable structures. They want to collapse into themselves.
So are we saying the universe is too wobbly to actually exist like that?
That's the million-dollar question. Now, to their credit, the researchers who came up with this theory knew about the stability issue, and they came up with some, let's call them, creative solutions.
Creative, as in it's the universe, so we're allowed to get a little weird creative.
Yeah.
Because I'm here for it.
Oh, you have no idea. We're talking hollow neutron stars and something called negative mass.
Wait, hold on. Back up a light year. Hollow neutron stars. Aren't those things already some of the densest objects in the universe? Like, a teaspoonful would weigh as much as Mount Everest.
You're exactly right. They're what's left after massive stars collapse, incredibly dense. But in this theory, they'd also be hollow.
Hollow. Like a cosmic ping pong ball. How does that even...
I know, right? We'll dig into how that's supposed to work in a bit. But first, what do you make of all this so far? I mean, a shell-shaped universe, hollow neutron stars. It's a lot to take in.
I'll admit, the whole hollow neutron star thing has me completely lost. It just seems counterintuitive. How can something so empty exert LES gravity? Isn't that the opposite of how gravity's supposed to work?
You'd think so, right? It's definitely a head-scratcher. But the researchers argue that these hollow neutron stars, for reasons that are still a bit fuzzy, wouldn't pull inwards as strongly as a normal, super-dense neutron star. And somehow, this weaker pull helps create a more stable shell overall.
Okay, I'm trying to follow the logic here, but are there any actual observations to back this up? Have we ever actually seen a hollow neutron star out there in the universe?
That's the big question, and sadly, the answer right now is no. As far as we know, hollow neutron stars are purely theoretical. There's no observational data, no widely accepted physics to suggest they could actually exist.
So it's like saying, well, if we assume unicorns are real, then we can explain why rainbows are so colorful.
It's an interesting thought experiment, but not very grounded in reality.
A perfect analogy. It's a fun idea to play with, but without any real-world evidence, it's highly speculative. And believe it or not, the researchers didn't stop there. They had a second trick up their sleeve to try and stabilize this shell universe, and it's even weirder than hollow neutron stars. Negative mass.
Oh yeah, negative mass. The thing that made me wonder if I'd accidentally wandered into a philosophy lecture. It sounds like something straight out of Star Trek. It does, doesn't it? But as strange as it sounds, mathematically speaking, negative mass is something that could potentially exist. Instead of attracting other matter with gravity, negative mass would do the opposite. It would repel it.
Okay, so it's like anti-gravity. Instead of pulling things closer, it pushes them away. My brain is officially starting to melt.
It's a lot to wrap your head around, for sure.
Yeah.
But here's the basic idea. If you had a point of negative mass right at the center of this shell universe, it would push outward on all the regular matter in the shell. It'd be like a cosmic tug of war, keeping the whole thing from collapsing.
Let me get this straight. We have a shell-shaped universe that needs imaginary hollow stars, A&D, theoretical anti-gravity just to exist without imploding. Is that about the gist of it?
You got it. And here's the thing. Even if we entertain the possibility of negative mass, it introduces a whole slew of other problems and contradictions when we try to reconcile it with our current understanding of physics.
So we've traded one set of mysteries for another even bigger, more mind-boggling set of mysteries.
Pretty much. But hey, that's how science often works, right?
Yeah.
You explore an idea, even a seemingly crazy one, and it can lead to some really interesting new questions and avenues for research.
I suppose even a wrong answer can be valuable if it points us in a new direction. But where does all this leave the shell universe theory? Is it just a fun thought experiment, or could it actually be onto something?
It's tough to say for sure at this point. It's a very new theory, very speculative, and it's facing some pretty major hurdles, as we've clearly seen. But it's also trying to grapple with some genuinely perplexing issues in cosmology.
Right, like the Hubble tension and those mysterious ingredients, dark matter and dark energy that we still don't fully understand.
Exactly. And sometimes shaking things up with a radical new idea, even if it turns out to be wrong, can spark some truly groundbreaking insights down the line.
It's like they say, if you always do what you've always done, you'll always get what you've always gotten. Maybe a little crazy is what we need to unlock the universe's biggest secrets.
I like how you think. It's crucial to keep an open mind, especially when dealing with these mind-blowing cosmic questions.
So should we be worried that we're all actually living inside a giant, unstable jawbreaker?
Not quite. It's fun to consider the possibility, but it's important to remember that extraordinary claims require extraordinary evidence. As cool as it sounds, the shell universe is still just a hypothesis, and a pretty shaky one at that. For now, the standard model of cosmology, with all its quirks and mysteries, remains our best explanation for how the universe works.
Okay, that makes me feel a little bit better, grounding us back in reality a bit. But it does make you wonder, if the universe isn't a shell, what other mind-blowing structures might be out there, hidden from our view? What else are we missing?
That's the beauty of science and exploration. There's always more to discover, more to learn, and more questions to ask.
Speaking of which, we've covered a lot of ground here today. We've talked about this wild idea of a shell-shaped universe, explored its implications, and even grappled with hollow neutron stars and negative mass. But before we get lost in the cosmic weeds, I think it's time to bring it back to you, our amazing listeners.
Absolutely. After all, it was your curiosity that sparked this entire deep dive.
Exactly. So we want to leave you with a final thought to ponder. What do you think about all of this? Does the idea of a shell universe intrigue you, or does it seem too far-fetched? What other strange structures or phenomena do you imagine might be lurking out there in the vastness of space?
It's definitely a lot to process, that's for sure. We started with this simple idea of a smooth, uniform universe, and now we're imagining it as a giant, possibly unstable jawbreaker held together by hollow stars and anti-gravity.
It's a wild ride, no doubt.
Yeah.
But hey, even if none of this turns out to be true, even if the shell universe is just a really cool thought experiment, it makes you appreciate how much we still don't know about the universe, right? Absolutely. It's humbling, in a way. For all our scientific advancements, for all the amazing things we've discovered about the cosmos, there's still so much out there that we're just scratching the surface of.
Exactly. And who knows, maybe someday, with even more advanced telescopes and a deeper understanding of physics, we'll be able to answer these questions with more certainty. Maybe we'll find evidence of a shell universe, or maybe we'll discover something even more mind-blowing that we haven't even imagined yet.
Or maybe, just maybe, the real value in exploring these big cosmic questions isn't about finding the right answer at all. Maybe it's about the journey itself, the process of asking these questions, pushing the boundaries of our understanding, and being open to the possibility that the universe is far stranger and more wonderful than we ever dare to imagine.
I think that's a beautiful way to put it. It's not always about the destination, but the journey, the exploration, and the constant pursuit of knowledge.
Absolutely. And on that note, we're going to have to wrap up this deep dive, but we want to thank you, our incredible listeners, for joining us on this wild ride through the cosmos.
It's been an absolute pleasure exploring these mind-bending ideas with you.
If this shell universe theory has sparked your curiosity, and let's face it, how could it not, be sure to check out the show notes for links to the research and articles we discussed. And remember, the next big scientific breakthrough might be just around the corner, inspired by your questions, your curiosity, and your willingness to embrace the unknown. So keep looking up, keep asking those big questions, and we'll catch you in the next deep dive.